Okay, so this is our loading condition. Okay, so let's find the formula. So normal stress. Okay, so px or stress x is equal to minus px over a, right? Minus again m z over izz multiplied by y. Okay, so our area is equal to, we are going to let C be the radius of the circle of the shaft. Okay, so we know that area is equal to pi c squared, right? And then we also know that izz, because it is a shaft, izz is equal to pi c 4 divided by 4. Okay, so now we know all this, so we now can compute stress x. So stress x is equal to minus 2500 divided by pi c4. Okay, and then not pi c4, really the squared. Okay, let me write properly. Pi c squared, and then minus by mz. We did calculate mz earlier, so mz is equal to 1800. Okay, so 1800 divided by pi c4 over 4, and then the y over here, right, correspond to the radius c. Okay, and then from here we can simplify this expression over here. So this is equal to minus 2500 over pi c squared. And then we can have minus, so we can cancel the c. This is pi c cubed. And then we have 18,000. 18 is 72,000. And then I would like to make this having a common denominator. So minus 2500c minus by 72,123, and this is divided by pi c cubed. Okay. So this is our, for this problem, this is our equation 1. So we have identified our stress x. Okay, we know that stress z, right, is equal to 0 because there is 0 stress in the z direction. And now we need to identify what is our shear xz. Okay, so the shear xz is due to the applied torque. So the formula that we're going to use, the shear xz, is equal to Px C over J. Okay, and then we know that J is equal to 2I. So we have found our I. So 2I is pi C4 over 2, right? So that is our I. And then from there, right, from there, we can directly write that the shear xz is equal to Tx. So Tx is 27600 multiplied by C divided by pi C4, the whole thing divided by 2. So I will tidy things up. So it's 27600. No, not 27. I'm going to bring up the 2. So 27600. So it's equal to 55200 divided by pi c cube. Okay, divided by pi c cube. So from here, all we need to do is just plug everything into this formula over here, as you can see. Okay, so tau max is equal to what? Square root of stress x plus by stress y divided by 2, the whole thing squared, plus by shear x, not y, sorry, z divided by 2 squared, plus by shear xz, the whole thing squared. Okay, so we know that one side, right? On one side is 50 times 10 to the power 6. Oh, is it 50 times 10? Yep, it is. So this will be equal to square root. And then we have stress x. So stress in the x direction is minus 2500 C minus by 72,123. And then you divide by 2 IC cube and the whole thing squared. Now stress Z, we know that this is equal to what? This is equal to 0, right? And then we just have to plus 55200 divided by pi c cube and the whole thing squared. Yeah. So now one equation, one unknown. It is yeah, it is solvable. I like to say that it is solvable, right? So now what I'm going to do is I'm going to bring the square across. So 50 power 6 squared is equal to 50 power 6 squared is equal to 50 power 6 squared, bracket 50 power 6 squared is equal to 2.5 times 10 to the power 5. Oh, times 10 to the power 15, not 5. 15. And this will be equal to minus 2500 C minus by 72,123 divided by 2 pi c cube, and then this thing squared plus by 55, and this is over pi c cube in squared. I like to bring, so all these are just math now, right? Let me, even though it's just math, I would like to show you. Okay, I know you guys say Eugene is just algebra. I understand that, but I want to show you. I understand that this is simple algebra. Okay. So we have this term over here. Yeah. So we have to come up, you have to make it to a form that we can use our calculator to solve it. Okay, so I'm going to simplify this further. I'm going to bring the 2 out. Okay, so the 2 squared, so 4 multiplied 2.5 times 10 to the power 15. So this will be equal to minus 2500 C minus by 72123 divided by pi c cube. whole thing squared, plus by 4 on the outside, 55200 over pi c cubed, the whole thing squared. Okay. So the denominator now, both are the same. So 2.5 power 15 times 4 is equal to 10 times, hold on, 50 power 6 squared, okay, times by 4. So it's 10 times 10 to the power 15 now, okay. So 10 times 10 to the power 15. And the denominators are the same. So this is pi squared C6. And then this whole thing will be equal to minus 2500C minus 72023 squared plus. So we can do the 55200 squared times by 4 is equal to 12.188 times 10 to the power 9. Okay, and let me do it again. 55200 squared times 4. Okay, 1.12 point. Okay, so from here, and then the next thing we do, we expand the term over here. So 10 times 10 to the power 15 pi squared C6. Somehow I made a mistake down here. I thought it was in megapascal. No wonder it looks weird. So this is 50 times 10 to the power 3. It's not in Pascal, okay? It is in PSI. So 50 power 3 squared is equal to 2.5 times 10 to the power 9. Okay, my bad. Okay, so 2.5 times 10 to the power 9. So times 2.5 power 9 times 4 is equal to 10 times 10 to the power 9. That's more like it. Okay, 10 power 9. So this whole thing will be equal to 25. So 6.25 times 10 to the power 6 c squared. Okay. And then we're going to have plus by 2 times by 2500 times by 72123 is equal to 360 times 10 to the power 6 c. And then we have plus is equal to 5.184 times 10 to the power 9. And then we have to plus 12.188 times 10 to the power 9. Okay. So from here, we simplify everything. Okay. So we bring everything across. Okay. 10 to the power 6, all of them are 10 to the power 6, 10 to the power 6, 10 to the power 9, I change to 3, 10 to the power 9, I change to 3, 10 to the power 9, I change to 3. Okay, so this in the end will get 10 times 10 to the power 3 pi squared C6 minus by 6.25 C squared minus by 360 C, and then minus by 5.184 plus by 12.188 is minus 17.372. Okay, so let me do it. 5.184 plus by 12.188 is equal to 14.372. Wait. 17. Why do I get 14? 5.184 is equal to 17 minus 17.372 times by 10 to the power 3. The whole thing is equal to 0. Then from here, I'm going to post a video on how to use the solver. So we use our calculator solver. Okay, I'm going to post, after our class, I'm going to post this online. Okay, we're going to use our solver. And by using the solver, C is equal to, wait, let me check my way. C is all, you can use Excel also, but in the exam, there's no Excel. Okay, so over here, as I say, I will link you guys to a video to how to solve for this. So in the end of the day, C is equal to 0.7493 inches. And the diameter is equal to, so 0.7493 times by 2 is equal to 1.4986 inches. Okay, so this is your answer. Okay, what I'm going to do, I'm going to stop here. Okay, as I said, I'll post a video on how to use the calculator solver to solve for an expression like this. Okay, if that's the case, I'd like to thank you for your time, and I'll see you guys next week.